All right, continuing on with this concept of normalization, let's talk about data tables versus lookup tables. Now, generally speaking, data models contain two different types of tables. Data, sometimes known as fact tables, and lookup or dimension tables. And the way to kind of differentiate between the two is that data tables contain those quantitative metrics, the numbers or values that you really care about. Typically, these data tables are pretty granular, detailed level, with ID or key columns that can be used to create table relationships to lookups. Now, on the other hand, lookup tables, they provide descriptive, often text-based attributes or characteristics about each dimension in a table. So you remember in the last lecture, I talked about each table in a model serving a specific and distinct purpose. Well, that's exactly what lookup tables are doing. They're providing rich information and attributes about things like customers, like products, like dates. And that's exactly the role that they play within our model. So let's walk through an example here. This blue table is a data table. It contains numerical values, those quantities, along with two key columns that we can use to connect this data table with some lookups, a date column and a product ID column. So what we'll be able to do is take that date column and connect it to a date column within a calendar lookup table. And the entire purpose of the calendar lookup table, its entire reason for existing, is to provide additional information about each date. So it's got one row per date and additional attributes like the day of the month number, the year, the weekday, and so on and so forth. So the bottom line is that if you know the date, you also know all of this additional information about months, quarters, years, weeks, etc. And the calendar lookup provides or gives us access to that information. Same story holds for the product ID. That product ID column in our data table can connect to or relate to a matching product ID in a product lookup table. And that product lookup table's purpose is to provide all sorts of product-specific information about each ID. So similar concept to the calendar table, just in this case, if you know the product ID, then by definition, you know the brand, you know the product name, you know the SKU, the retail price, the cost, the weight, and any other product-specific attributes captured by this product lookup table. So in order to understand the real mechanics of how these relationships work, one of the first things we need to dig into is the idea of primary versus foreign keys. Now consider the same set of three tables: our blue data table, our green calendar, and our orange product lookup table. Consider the date and product ID columns in our data table. These are called foreign keys. They're keys because they're used to create relationships with our lookup tables, and they're foreign because they contain multiple instances of each value. And this is the case with many data tables. Here we have multiple transactions and multiple quantity values per day, and multiple transactions and quantity values per product ID. So we could potentially see many duplicate values in both of those date and product ID columns. Now when we look at the same columns in the lookup tables, date in the calendar table and product ID in the product lookup table, these are called primary keys because they uniquely identify each row of the table and they match the foreign keys in any related data tables. So it's easy to mix these up, but as a rule of thumb, primary keys are unique, foreign keys often contain duplicates. So let's jump into Power BI. I want to open up the relationships view and see if we can identify some of these primary and foreign keys in the AdventureWorks tables that we're working with. Alrighty, so once you've got your file open, we're going to go ahead and navigate to the relationships view. And we're going to be spending a lot of time here because this is where the data modeling magic really happens. And the first thing I want to do is just looking at these tables that we've got, I want to identify which are data tables and which are lookup tables. Now we've already started hinting at this quite a bit. We know that the one table that contains our quantitative metrics, the values that we care about, the order quantities, is our AW sales table. So let's grab that. I'm just going to pull it down to kind of distinguish it from the lookup tables. So now we know this is our data table. Looking up at our other tables, product lookup contains all sorts of information about products. Customer is all obviously focused on customer level information. Calendar is all about dates. Territory has information about sales regions, countries, and continents. And then we have some additional product related category and subcategory tables that are almost getting orphaned off here. So come on back, guys. So all of these tables serve very specific, distinct purposes. And I'm kind of an OCD person, so I'm going to drag the product lookup table over here with its friends and click and drag and just rearrange things a bit. We're going to be doing more designing in here, but there we go. So at this point, we know which tables are lookup tables, and we know which tables are data table. Let's take a quick pass through and see if we can identify our primary and foreign keys. So starting with our lookups, customer lookup clearly has a customer key that uniquely identifies each row within this table, and therefore uniquely identifies all of this information about customers. Calendar lookup, same story here. It's not called a key, but the date serves that purpose. If you know the date, you know all of this information about that date, the month, the week, the day of the week, and so on and so forth. Territories, we've got a clear sales territory key here, which maps to regions, countries, and continents. And then products are a little bit more complicated. We're going to get into this later when we talk about snowflake schemas. But what you may notice is that some of these tables actually contain more than one key. But for the time being, pretend like you never even saw that. Now shifting down to the data table, let's talk about foreign keys. So we know that multiple sales take place per day. So both of these date fields, order date and stock date, are both foreign keys because there are multiple instances of each value, and those dates can tie into the date field of our calendar lookup. Similar story with product key. We've got multiple sales per product. Same with customer key, same with territory. So all three of these keys plus the two dates make up our foreign keys within the data table. So that's about enough for now. That's your crash course in data versus lookup tables and primary versus foreign keys.